Assalamualaikum warahmatullahi wabarakatuh. Today I want to share about a simple video chemistry about discovery alcohol through the mind mapping. Next is group members. First is me, Muhammad Irfan bin Daud. Second, Muhammad Amirul Izzam bin Muhammad Zaidi. Third, Muhammad Amir Amirul bin Daud. And the last is Muhammad Faris bin Hamizai. And then is our content. First, introduction about alcohol. Second, attractive approach about alcohol. And next, use in daily life about alcohol. And lastly, conclusion about alcohol.
Introduction to alcohol. Alcohol, also known as ethanol, is a chemical compound commonly found in beverage such as beer, wine, and spirit. After that, alcohol is a simple organic compound with the formula C2H2 and OH. There is four attractive approach to learn alcohol. Firstly, classification. Secondly, IUPAC nomenclature. Thirdly, properties. And the last one is reaction. There is four types of classification alcohol. Firstly, primary alcohol, which is OH group attached to the single atom of carbon. For example, ethanol. Secondly, secondary alcohol, which is OH group attached to two atom of carbon. For example, 2-butanol. For the last one, tertiary alcohol, which is OH group attached to 3 atom of carbon. For example, 2-methyl propanol.
So for my second point, I'm going to talk about IUPAC nomenclature. In IUPAC nomenclature, we have two types of alcohol, that is aliphatic alcohol and aromatic alcohol. In aliphatic alcohol, first we need to select the longest carbon chain with OH group attached to it. Second, we must number the carbon atom in this chain so that the one bonded to the OH group has the lowest possible number. Third, we form the parent alcohol name by replacing the final A of the corresponding alkane name by OL. And lastly, we name each alkyls brands or other group and design it position by a number. And for aromatic alcohol, in most cases, the name phenyl is used as the parent name. Now, I'm going to talk about properties of alcohol. Boiling point of alcohol. The boiling point of alcohol are higher than those of alkenes and chloroalkane of similar relative molecular mass. Next is the solubility of alcohol in water. First, alcohol with short carbon chain such as methanol, ethanol, and propanol dissolve in water easily. Second, the solubility of alcohol in water decrease sharply with the increasing length of carbon change. Higher alcohol are insoluble in water. To make it easily to understand, the more carbon the alcohol have, the harder it to solute in water. Now, if you look at the table below, you can see that simple alcohol that have less than 12 carbon, its physical form is liquid and colorless. Meanwhile, alcohol with carbon more than 12, the physical form is solid. So now I'm going to talk about the reaction of alcohol. If the alcohol react with sodium at room temperature, it will form a salt, or other name is sodium alkoxide and hydrogen. Meanwhile, if the alcohol is react with carboxylic acid, it will form a ester and H2O.
The use of alcohol in daily life. Alcohol is a powerful disinfectant help kill germs, bacteria and viruses. Example of product used in daily life and sanitizer, rubbing alcohol, deodorant, cough syrup, disinfectant. Okay, move from that. Alcohol also serves as a solvent, preservative, and antiseptic in drug formulation and production. Example, formulation of syrup and sterilization of medical instrument. Ethanol and methanol are used as alternative fuel or fuel additive to reduce emission. Example, additive in gasoline to improve combustion and full alcohol stove and lamps. Now for the conclusion. The chemistry of alcohol is a fundamental to their diverse application and behavior in both biological and industrial contexts. Alcohol are organic compounds characterized by the presence of one or more hydroxyl group attached to a carbon atom. Their properties such as polarity, hydrogen bonding, and solubility in water make them versatile substance used in solvent, fuel antiseptic, and the synthesis of numerous chemicals. The reactivity of alcohol, including oxidation, acidification, and dehydration, underpin their role in organic synthesis, pharmaceutical development, and other industry.